So let's start. Question 4. So 4.1, they give us a graph. So they give us a graph. The graph is h of x is equal to -3 over x minus 1 plus 2. So we can recognize this graph as this one. Y is equal to a over x minus p plus q. And we know that this is an equation of a hyperbola. Okay, an equation of an hyperbola. And we know that because a is negative, the arms of the hyperbola will be in the second quadrant and in the fourth quadrant. Okay, that is what we are expecting. And we know that this guy, the p-value is the value of the vertical asymptote. So the vertical asymptote will be x is equal to p, or x is equal to 1. And then the horizontal asymptote will be y is equal to 2, or y is equal to q. That is just based on the features or the characteristics of a hyperbola. All of the stuff that I'm talking about, I just got it from just looking at the equation. Nothing much, nothing difficult. Okay, so let's continue. The first question, question 4.1.1, they say write down the equations of the asymptotes of h. We have already answered that question. So we know that the vertical asymptote is x is equal to p, and in this situation p is 1, so it's x is equal to 1. And then the horizontal asymptote is y is equal to q, so it will be y is equal to 2. So this one is done. And then 4.1.2, they are saying we must determine the equation of the axis of symmetry of h that has a negative gradient. Now you will recall when we were talking about hyperbolic functions, we said that a hyperbolic function has two axes of symmetries. Remember, an axis of symmetry is simply a straight line that divides the graph into two equal parts. So basically, it cuts the graph in half. That is the simplest way we can think about an axis of symmetry. Okay, so let's just do something that will enable us to answer this question. So let's say we have a hyperbola. Say we have a random hyperbola, and then his asymptote is like that. Asymptote is x is 1, x is equal to 1, and then the other one is y is 2. Let's put it there, y is 2. Okay. Okay. So let's put the graph there, and then the other one there. Okay, cool. So now what we can see is that there can be two axes of symmetries. We know this already. So one will be this one, the positive gradient, the straight line with the positive gradient. And then the one that we are interested in is this one, the one with the negative gradient. So it will pass there, pass there. Now, the most important thing, or one thing that will help us to answer this question, is to realize that this guy, the axis of symmetry, the one that we want the equation for, is passing at a point. Okay, and the coordinates of the point, we have the coordinates. Remember, x is 1 is the equation of the asymptote, and then the equation of the other asymptote is y is 2. Okay, so in other words, the coordinates of this point is what? X is equal to 1, y is equal to 2. So That is information number one. And then another information that we do know is that this guy has a negative gradient. So we know that the gradient m is -1. Remember, for asymptote, for hyperbolas, I mean, there are two symmetries. The other one has a positive one gradient, and then the other one has a negative one gradient. We know that already. Okay, so with this being said, we can simply determine the equation of this line, because number one, we can see that it's a straight line. So y is mx plus c, and then we can see that it passes to this point. We have established um, this thing, the coordinates of the point. So the coordinates of the point is x is 1 and y is 2. So we can use that, and then we can use the gradient as well, which is -1. Okay, so let me just remove the sketch, and then so we have a point. The point is x is 1 and y is 2, and then we have the gradient as well. The gradient is -1. Okay, so let's examine the equation. Remove that guy. Okay, let's do it on the side here. So the equation will be, so y is mx plus c, mx plus c. Now we know that the m is -1, so it should be negative x plus c is y, and then we have a point, so we basically plug in the point, and then we can solve for the value of c. Okay, to get the value of c, I mean. So y is 2, x is 1, so we'll have 1 there, and then plus c. So we take the 1 to the other side, it becomes +1, so the 2 plus 1 is equal to c, so c is equal to 3. Okay, now we have the value of c, so we can be able to write the equation of that line, which is the x of symmetry. So we say y is -x plus 3. Okay, so this is the equation. This is the answer for this question. Okay, and then finally they asked us to sketch the graph of A showing the asymptotes and the intercept with the axis. Okay, so it's very important for us to 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 understand what they want. Firstly, we must know that they want the sketch of this graph. Of course, we know that one, and then very importantly, showing the asymptote and the intercepts. So in other words, the x-intercepts and the y-intercepts, if they are present, of course, then we have to show them. So it means that there is no need for us to show random points on the graph, right? So as long as we have what we want, as long as we have the asymptotes, both of them, the intercepts, all of them, if they do exist, because in some instances you'll find out maybe there's a y-intercept only, the x-intercept doesn't exist, and so forth and so forth. So if both of them exist, then we show them on our graph, but then if not, then we show the one that exists, and then that's it. Okay, so we do not have to do a lot of work. Okay, so let's sketch. Let us sketch. Can remove this. Remove that as well. Let's do proper sketch. Okay. Okay. And then y, and the other one is x. And then the first thing that we have to take note of our asymptote. So x is equal to 1 is the asymptote. So let's put 1 there. Okay. So say x is 1. Here, x is 1. Put 1 there. X is 1. Okay, that's better. Y is 2, 1, 2, so I put Y is 2 there. Okay, okay, okay. Y is 2, put it there. Alright, cool. Now, to indicate that they're asymptotes, you can just do this. Okay, and then this one as well. So this is x is equal to 1, okay, and then this one is y is equal to 2, okay, the two asymptotes that we wanted us to show. We've done that, and then now let's look for the intercepts. Okay, so our equation is y is equal to y is equal to -3 over x minus 1 plus 2. Okay, so let's start with the x-intercepts first. So if we make y to be 0, let's do that. Make y 0. Okay, so say 0 is -3 over x minus 2 plus 2, x minus 1, I mean, plus 2. So what we'll do is we'll solve for x. So take the 2 to the other side, it becomes -2. Okay, x minus 1, and then we cross multiply. This is like that. So this times that, and that's times that. That being said, we get this -2 times x minus 1, and then we have -3 times 1, which will just be -3, -3, and then -2x plus 2 is -3, and then we can see that -2x is -3 minus 2. Okay, so it's -2x is -5. What does that tell us? It tells us that x is 5 over 2. Okay, positive 5 over 2. So that is the value of x, and then we know that 5 over 2 is 2.5. No? It's around 2.5 there. So if this is x is equal to 1, then x is equal to 2 will be, x is equal to 2 will be here, 2 will be here, x is equal to 2.5 will be somewhere here. Okay, so now this is our point. 5 over 2 is our point over here. Okay, so this is that one, and then we know that now we need to determine the y-intercept. Now the y-intercept, in order for us to do that, we must make x to be equal to 0. Let's do that. Let me just remove this. Okay, so if we want to make x 0, okay, we can do that. So it will be 0 minus 1 plus 2, and then plus 2, and then it will be -3 divided by -1. That one will give us +3. Okay, plus 2, and then we'll have 5. Okay, so the y-intercept is x is equal to 0, y is equal to +5. Let's go and plot the point. So let's see, 2 is here, 3, 4, 5. So the point is here. Okay, and we know that it's in the second and the fourth quadrant according to the value of A. So we know exactly how our graph will look. Okay, so this guy is y is equal to 5, so we can just write 5 there. And this guy is x is equal to 2.5, x is equal to 5 over 2, so we can just write 5 over 2 there. And then we can do our thing, can sketch, so it will be like that, that, like that. Okay, and then like this, and this side will be that, 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 like that, like that. Okay, so this is what our graph will look like. Okay, but this is how our graph will look like. So this is y is, they called it h of x. So let me call it h of x. H of x is equal to negative 3 over x minus 1 plus 2. It's minus 1 plus 2. Okay, so this is h of x, and we are done with the sketching of h of x. So that was a question. Now we are dealing with 4.2. So now if we look at the statement, they say that the graph of f of x is equal to this guy, this thing, and then the graph of g of x is equal to that guy. They are sketched below, and then they give us a lot of information. So before we even go through the information, let's analyze what they gave us from the equations. So we you see that they gave us an equation of this form: y is equal to x minus p all squared plus q. Now the p in this equation is negative 5, and then the q is negative 8. Okay, so from that we know that the coordinates of the turning point are given by x is equal to p, y is equal to q. Now, x is equal to p, remember, we said it's negative 5, okay? And then x is equal to, no, y is equal to q is negative 8, okay? Q is negative 8, so this is the coordinates of the turning point, okay? If we look at our graph, it is essentially the coordinates of A, because A is the turning point if we're looking at the graph. Okay, and then what else can we get from the equations? We can get that this guy is a straight line. We can see that, and the gradient is positive a half. The y-intercept is 9 over 2 or 4.5. So it means that at this point, the y value is 9 over 2. Like the y value at this point is 9 over 2. Okay, so that is what that means. Now we are ready to go through the statement. We can go through the statement now. Okay, so they say that A is the turning point of F. Okay, we've seen that already. The axis of symmetry of F intersects axis of symmetry, the axis of symmetry. Let's wait and go locate the axis of symmetry that they're talking about. They're talking about this line, the line that is the axis of symmetry of the parabola, this one. And they're saying that this line intersects the axis at E. So this line meets the x-axis at E, so that is what they are saying basically. We can see that because this line is meeting the x-axis at this point E, okay, and the line G at D, and we can see that this guy, which is the axis of symmetry of the parabola, is meeting the straight line at this point D. okay, which is basically what they're telling us. And then they're saying C is the y-intercept of F and G. Okay, this is C there, the y-intercept of the two graphs. Okay, so now we are ready to tackle the questions because we are familiar with all the given information. Okay, so let's get started. They're saying write down the coordinates of A. Now, remember, A is the turning point, and we have the answer, or we have the coordinates of A already because we have spoken about the coordinates of the turning point. So we know that -5 and -8. Okay, and then they say write down the range of F. Now, F is this guy, the parabola. F is the parabola. And remember that when we're talking about range, we're talking about all the y values that are associated with the graph. Now, if we look at this guy, the only possible y values that can exist in this graph, or the only possible y values that can be associated with this graph, is starting from A, including A, going upwards. In other words, there is no possibility for a y value to be below A, because we don't have any graph at A. We don't have any graph below A, I mean. So our range is y, our range will be y is greater than or equal to -8, which is basically the y value at point. Okay. Uh, okay. And then 4.2.3, they're asking us to calculate the values of m and n. So in other words, determine the coordinates of d. Okay, this is what they want. They want the coordinates of that guy. Now, we have what we have, all the information that we have. Let's just put it in there so that it can be able to help us. Okay, so this guy is -5, -8, and then we have the equation of the straight line. This one is g of x, the straight line is g of x. Now, we want the coordinates of, let me just remove, want the coordinates of this point, right? Point D, the point whereby the graph of G is meeting with the A of S, or the axis of symmetry of our parabola. So we are looking for the coordinates of this point. How do we go about to do so? Now, one thing that we have to recognize is that at this point, number one, the first thing that we need to recognize that this point lies on the graph, right? On the graph of G. So whatever that we do, we have an equation that we can use. So we can say y is equal to 1 over 2 x plus 9 over 2. So this is the equation of G. Okay, we can use that guy. And then we know the x value of point A is the same as the x value of point D, because this AD is a vertical line, right? It's a vertical line, so they have the same x value. So with that being said, we know that m is equal to -5. Okay, the x value of d is -5. Now the question is, how can we get the y value? Very simple. We have the equation of g. So now we know that the x value at point d is equal to -5. So what can you do? You can simply substitute the x value here and get the y value. So we'll put -5 there, and then we can work this one out. So it will be -5 over 2 plus 9 over 2. So we'll get 4 over 2, and then 4 over 2 will simplify to 2. Okay, so our answer is 2. So the y value at D is equal to 2. So in other words, the coordinates for D, okay, is -5 and +2. Okay, so M is -5, and then N is what is 2. Okay, and then now we can do the following question. So remove this, and then we can remove that as well. You can just write the coordinates. So D is what, -5 and +2. Okay, so these are the coordinates of D. And then now let's go to 4.2.3. They're saying calculate the area of OCDE. Okay, let's see what kind of shape is this one. Okay, so it's a different color. So OCDE. Okay, so this is the thing that they're talking about. So this is the shape that they want us to determine the area of. Now, if you can see the shape is a well-known shape basically. Actually, this shape is what we call a trapezium. Okay, this is a trapezium. Now, a trapezium is a quadrilateral with one pair of opposite sides parallel to each other. So this is an example of a trapezium. Why? Because one pair of opposite sides are parallel to each other. This guy and that guy, they are parallel to each other. So this qualifies to be a trapezium. And if we recall from our geometry knowledge that the area of a trapezium can be simply determined because we have the equation for that. It's basically the area is it's half the sum of the two parallel lines. So in this situation, it will be half of DE plus the length of OC. So it's half times the length of DE plus the length of OC, and then times the distance between the parallel lines. So it will be multiplied by OE. This is the distance between the two parallel lines. OE. And then we can solve this. We can say a half. Now we know that the y value at point D is equal to 2. So we immediately know the length of DE to be 2 because DE is just a vertical line. Okay, so this is 2, and then OC is this distance from O to that point C. Now we know that the y value at point C is 9 over 2. So it means that the distance OC is equal to 9 over 2. 9 over 2. And then we can multiply by the distance of OE. Now, O is here, E is there. Now, the x value of E is what? Is -5. Okay? X value is -5. Now, the distance is not -5. The distance between there to there is +5. Distance is always positive. Okay? So, this one will be +5. And then if we put this in our calculators, we can see that we find, I think it's 16 over 4. Just double check. Yes, it is indeed 16 over 4. So the area of this trapezium is 16 over 4 units units squared. Okay, so remember that the area is in units squared. So since they didn't specify, or since they didn't give us any units, we have to um, involve the units squared. Okay, so that was 4.2.4. Now let us look at 4.2.5. Now 4.2.5 is a very interesting scenario because they want us to determine the equation of g to the negative 1. Okay, so we just um, so this guy is 16 over 4 units squared. Okay, and then now we want the inverse of the graph of g. Okay, so let's remove that. Removing that. Now, you will recall that an inverse graph is the graph that we obtain if we take the graph that we have. In this situation, if I take the graph of g and then I flip the graph of g across a line, I flip the graph of g across this line, Mm, across this line. Now the line will be this one, yeah. Y is equal to x. So this is the line. Y is equal to x. Now, if I take this graph, the graph of g, and then I flip it over this line, um, if I take this graph, no, this is the graph. If I take this graph and then I flip it over this line, what is the equation of the graph that I will get? Okay, so we spoke about this in our previous sessions. We said that in order for us to get the equation of an inverse function, we take the equation of the original function and then we swap. We swap x, we swap y, and then we make y the subject of the formula. So that is easy as that. So let's do it. Right. So we know that the function um, y is equal to a half x plus 9 over 2, I think. Yeah, plus 9 over 2. And then, so to get the inverse in, my handwriting is scared. So to get the inverse function, so this is the function, and then the inverse function can be determined by swapping them around. So the x will be there, and then the y will come there, and then after that we can make the y the subject of the formula. Okay, so we can say x, take the 9 over 2 to the other side, becomes minus 9 over 2, and then this is equal to 1 over 2 times y. Now, we want y to be the subject of the formula, not 1 over 2 times y. So what can we do to isolate y? We can multiply everything by 2. Okay, so we can say 2x, 9 over 2 times 2 will just be 9, and then this one will be y. So basically, the equation of the inverse function is this one. Y is 2x minus 9. Okay, so this is the answer for our last question, 4.2.5. Okay.